Hello and welcome to Empowered Learning. This particular video is the second video in the graphing transformation series, and for this video we're going to do some examples of how we take the points of a basic parent function and use those to be able to morph those points into the points needed for a resulting function that we want to graph. So the example that I have here, if we look, is that we have this function here, which is negative square root of x plus 2 plus 3. And what we want to do is start off with what the parent function is and change the points that we pick for the parent function, or from the parent function, in order to come up with a result of what the graph would look like for the function with all the transformations. So this is one short example. So we know that since this has a square root in it, its base function is going to be y equals square root of x, okay? And so if we follow the transformations in order of operation, meaning if I plugged in the x value right here, what would be the first thing I would do? Of course, I would add 2. So that means that this transformation of a horizontal shift to the left should be the first transformation to do. Now, from our base function points here, which I've just named some, since this is a square root of x function, we know we cannot pick negative values for x to start off with, so I just started off with 0 and picked all x values that had perfect squares to make my life easy. So here we know we have 0, 0, 1, 1, 4, 2, and 9, 3. So from that, we see that if we're doing a horizontal shift to the left, horizontal tells us deal with x values. Shift tells us to add or subtract. And of course, since we're going to the left, that definitely solidifies that I need to subtract. So I need to subtract 2 from all of the x values. And so if you see here, 0 minus 2 is negative 2. 1 minus 2 is a negative 1. 4 minus 2 is 2. And 9 minus 2 is 7. Since we had only a horizontal motion, the y values would stay the same. And so now what we need to do next is add the next transformation, which we see that in terms of order of operation, that would be the negative that's right here. And of course, that would be a reflection about the x-axis. So we would take all these points here from above for the y equals square root of x plus 2 type function deal. And we would multiply all the y values by a negative 1. So of course, taking all those values there, we see that we have 0 times negative 1 is 0, 1 times negative 1 is negative 1, and so on and so forth. We just make the y values the negative of what they were. Okay? And so now, after we're done with the first transformation and the second, of course, the third is the plus 3 here, which is a vertical shift up 3 units. So in that case, we would take all of our y values and we would add them by 3. Okay? And so, of course, we see the results here. And if we were to graph these functions here, then it would look something like this. We would have our original function kind of look like this, and then we would have that same function kind of look like this, but shifted over to the left 2 units. After that, we would apply the negative, which would be the reflection about the x-axis. And then the last thing that we would do is do the plus 3. So that would be vertical shift up. And of course, our resulting graph should look something like this. And if we look at our next page, which I'll go ahead and flip to it now and reduce, you'll see that that's exactly what this looks like. We have our base function, which looks like square root of x. Then we move it over 1, 2 units. And then from there, we flipped it or reflected about the x-axis and then pushed it up 3 units. Okay. And so now we're going to do another example where we're starting from scratch. All right, so in this instance, we see that we have the function y equals -2 times absolute value of x plus 3. So in this case, we know that our base function here is going to be y equals absolute value of x. And so if we pick some points here, we'll pick -2, -1, 0, 1, and 2. And so, of course, absolute value of all these numbers, absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. So our first transformation, if we look at it, and I'm going to list all these in words first before I started doing the other stuff, is that we know here if we plugged in a value for x, the first thing that we would do is add 3. So that's going to be our first transformation. Of course, the 2 that is here would be the second. And the negative that is right here would be the third. Okay. All right, so knowing this, let me come down just a second. We know that our first transformation, we have a +3 on the x there. So what that's telling us is that we have a horizontal shift to the left 3 units. Okay, and of course that would change this to x plus 3 from absolute value of just x. And so since this is a horizontal motion here, then our x values would change by subtracting by 3. So -2 minus 3 is a -5. -1 minus 3 is a -4. 0 minus 3 is -3. 1 minus 3 is a -2. And 2 minus 3 is a -1. And of course, all of our y values will stay the same. Okay. So that takes care of 1 for us. And so now we're going to go ahead and go on to 2 here. So our second transformation, after we've taken care of the +3, is of course just the 2. And again, I want to reiterate, we do not look at this as -2. We look at this as negative and 2 as 2 separate transformations. Okay? So we'll come here and we'll say that the transformation is that we have a vertical stretch by factor of 2. Okay? And then from there, we'll write in the algebraic version of this, which would be 2 times absolute value of x plus 3. And of course, since vertical tells us that we're affecting the y values and stretch tells us that we're going to multiply, we're going to be multiplying all of our y values by 2 and keeping all the x values the same. So y values we just multiply by 2, and we keep all the x values the same. Okay. And then the last thing is to deal with the reflection that we have, which is our negative that we see right here outside the 2. And so that would be a reflection about the x-axis. And again, a reflection about the x-axis is a vertical motion. And so since that's a vertical motion, we know that we're going to be changing all of our y values by multiplying them by a -1, which essentially just changes the sign of them. And then, of course, the x values stay the same. And so now, if we had all these points, then of course we can go on our graph and plot them and see that we would start off having a function that looks like this. And then we would eventually have a function that looks like this, where everything shifted over 3 units. And then for the next one, we would have everything stretched. So now it would look skinny like that. And then, of course, to end it, we would basically have the reflection about the x-axis there. Okay, so that would be more like that, and it would be skinny. All right, so we'll go ahead and do one more example. All right, so for this example, we have the function 1/2 times square root of negative x minus 1, and I'm going to exclude this minus 3 here because we don't have enough room to do all those transformations there. Okay, so we'll just deal with 1/2 of square root of negative x minus 1. Okay, so here we know that our base function, again, is square root of x. And so here our first transformation, if we look at this according to order of operation, would be the negative that's on the x right there, which would be a reflection about the y-axis. Okay, and then after that, this minus 1 that we see here would actually be a horizontal shift to the right 1 unit. And then, of course, the last thing would be this 1/2 here, which would be a vertical compression by a factor of 1/2. Okay. So our key points again for square root of x: 0, 0, 1, 1, 4, 2, 9, 3. Okay. And so then what this would morph into to start off would be y equals square root of negative x. And then for the next transformation would be square root of negative x minus 1. I'll go ahead and put that there, make it look better. And then the last one would be, of course, with the 1/2 on there. So we start off by doing a reflection about the y-axis. That means that is a horizontal motion, so we will be multiplying all the x values by a -1. And if we do that, then we get those numbers as a result. For the y values, we would do what? That's right, we would keep it the same. So come here, and then from that point, we'll go on to the next one, which is y equals square root of -1 minus 1. So now the thing that's added is the appendant -1 here. So because of that, we know that -1 on an x value would be a horizontal shift to the right. Okay, so in doing that, that means horizontal shift tells us we affect our x values. So we're going to come here and basically add 1 to all of our x values. So that would be 1, 0, and then 0, 1, and then -3, 2, and then -8, 3. Okay. And then once that's done, then we do the last one, which is applying the 1/2. And so the 1/2 that is there, of course, is a vertical compression, so we're multiplying all of our y values here by 1/2. And we keep all the x values the same at this point. So if we do that, that would be 0. 1/2 times 1 is 1/2. 1/2 times 2 is 1. And 1/2 times 3 is 3/2. And so if we wanted a depiction of what the graphs look like, the basic function would look like this. The reflection about the y-axis, of course, would look like that on the other side. And then from there, 1, we would have something that kind of looks like this. And then, of course, the last thing is the compression. And so, of course, if we have that, that would kind of be skinny and look more so like that. I think I'm going to draw that again, make it look a little better. Makes it kind of look like that instead of stretched up. And so the idea here is that if you can take any function, get key points from it, and then apply the transformations point-wise to get the graphs, then you should be able to figure out the graph of any function, regardless of whether it's a basic one or if it has transformations to it. And this concludes the video on graphing transformations.